Right now, something is passing through you. You'll never detect it, never feel it. It may have existed before the first star ever ignited. There are 5 types of black holes, each one stranger than the last. The final one sits exactly where human knowledge ends and stops. A star dies, not quietly, violently. In under a second, a core collapses. The explosion that follows briefly outshines every other star in the galaxy combined. And when the light fades, something is left behind that has no business existing. City-sized, the mass of dozens of suns. Gravity so extreme that space itself curves closed around it. This is a stellar black hole, and it is completely invisible. No light, no signal, no warming. The only way we know they exist is by watching what disappears near them. Gas torn from a neighboring star, stars that orbit something that isn't there. When we piece those clues together, the conclusion is always the same. Something is there, and it isn't letting go. Cygnus X1 was the first one we confirmed. Stephen Hawking bet against it. He lost. There may be millions more scattered across the Milky Way right now, invisible, silent, waiting. These are the smallest, the most understood, and they're already deeply unsettling. But they are nothing compared to what comes next. Here is a gap in the universe that shouldn't exist. Stellar black holes top out at around 100 solar masses. Supermassive black holes start at millions. That's an enormous range where black holes should exist. Hundreds, thousands, tens of thousands of solar masses. We've barely found any, and that absence is the problem. These aren't hidden because they're rare. They're hidden because they're quiet. They don't feed enough to glow, don't dominate enough to stand out. The only evidence they leave is gravitational. Stars near them orbit wrong, move too fast, bend in ways that only make sense if something invisible is pulling them. One candidate sits 290 million light-years away, estimated at 20,000 solar masses. Not confirmed, but the alternative explanations are worse. They may be the missing link between stellar remnants and galactic monsters. Without them, the universe's largest structures have no clear origin story. Something is there. We just can't catch it standing still. At the center of almost every large galaxy in the observable universe, including ours, something is anchored in the dark. Not a stellar black hole, something categorically different. Millions, sometimes billions of solar masses compressed into a single point, so gravitationally dominant that it doesn't just affect nearby stars, it determines the fate of the entire galaxy surrounding it. Ours is called Sagittarius A star, 4 million solar masses, 26,000 light-years from Earth. We cannot see it directly, but we can watch the stars near it, and they move in ways that have only one explanation. Something invisible is holding them hostage. Some complete a full orbit in just a few years, whipping around a galactic center at speeds that shouldn't be possible. In 2019, we photographed one for the first time. Not an illustration, an actual image. A ring of superheated gas glowing around an abyss so deep that light, traveling at 300,000 kilometers per second, cannot climb out of it. The image was humbling in a way that is difficult to describe. But here is what's truly unsettling. Every large galaxy we've studied has one, which means these aren't accidents of physics. They are the architecture. Remove them, and galaxies as we know them don't exist. And yet we still can't explain how they got so large so fast. Some existed fully formed less than 1 billion years after the Big Bang. The universe wasn't old enough for that to happen by any process we understand. Something seeded them, and the answer may be older than the stars themselves. Before the first star, Before the first galaxy, in the first fractions of a second after the Big Bang, the universe was dense, chaotic, and unimaginably hot. And in that chaos, gravity may have taken over on the spot. No star needed, no collapse, just raw density crossing a threshold. Primordial black holes. If they exist, they are the oldest things in the universe, and they may be everywhere. Some could be smaller than an atom with the mass of a mountain, others far larger, and they may be the answer to one of science's most stubborn unsolved problems: dark matter. Something holds galaxies together that we cannot see or detect. One possibility, it isn't exotic particles at all. It's primordial black holes, trillions of them, drifting silently through the cosmos, passing through our solar system, through Earth, right now, without leaving a trace. We haven't confirmed a single one, but the math keeps pointing in their direction. Something was there at the beginning, and it may still be here. Every black hole so far has existed at a scale we can at least attempt to picture. A city, a galaxy, the beginning of time. This one doesn't. Quantum black holes, if they exist, sit below the threshold of what space itself can meaningfully describe, the Planck length, so small that calling it tiny doesn't come close. At that scale, the two frameworks we use to explain reality, Einstein's relativity and quantum mechanics, stop working independently. They're forced into the same room, and they don't agree on anything. We've never unified these two theories. Quantum black holes are not just a curiosity, they are a forced confrontation with the single biggest gap in our understanding of physics. If one could be observed, even briefly, it would hand us a clue towards something physicists have been chasing for a century: a theory of everything. They would evaporate almost instantly, gone before we could measure them. The Large Hadron Collider may have briefly created one during a high-energy collision. We don't know. The evidence wasn't there. But the stakes are too high to stop looking. These are not about devouring stars or shaping galaxies. They are about the edge of knowledge itself, where our current theories fail, where the next version of physics has to begin. Every detection, every image, every gravitational wave reaching our instruments is another piece of a picture we haven't fully seen. We're still in the early chapters. But before we leave, there is one more kind worth understanding. Not theoretical, not unconfirmed, one we have actually witnessed, and it may be the most violent thing the universe has ever produced. Black holes usually drift alone, but sometimes gravity pulls two together. They orbit, slowly closing the distance over millions of years until they finally collide. That collision releases unimaginable energy, sending ripples through space-time itself, gravitational waves. These waves travel across the universe, passing through everything, even us, almost unnoticed. In 2015, we detected one for the first time. It changed how we observe the universe, and it leaves a question: what else is happening around us that we still can't detect? 5 types, each one stranger than the last, each one pushing further from what we can see, touch, or test. The universe doesn't get simpler the deeper you look. It gets stranger, and the questions get harder. We still don't know what dark matter is. We still don't know how supermassive black holes grew so fast. We still don't have a theory that unifies gravity with quantum mechanics. Black holes sit at the center of every one of those unsolved problems, not as answers, but as pressure, forcing physics towards something it hasn't found yet. Every detection, every image, every gravitational wave reaching our instruments is another piece of a picture we haven't fully seen. We're still in the early chapters.